All right, we are back with example 3. We're going to be proving parallelograms in the coordinate plane. Okay, so remember a coordinate plane, that's something that has an x and a y axes, right? So here's our y, here's our x. So here's our x, here's our y, right? And we plot points and figure out things, okay? So we're going to be proving parallelograms in the coordinate plane. So let's go ahead and look back here, right? To parallelograms. And let's think about these in the coordinate plane. So if we had something like this, how would we prove this is a parallelogram? So for this first one, you have to show that the sides are congruent and they're parallel. So if we're thinking about the coordinate plane, we would be using the distance formula to show two distance formulas to show that these two sides are the same length. Okay, but how would we show that they're parallel? Well, we'd have to use a slope formula, right? M equals y2 minus y1 all over x2 minus x1. So you'd have to find the slope of this, and you have to find the slope of this. And if they have the same slope, then you know that they're parallel. So for this one, it would be two distance formulas and two slope formulas, all right? What about this one? How would we show this was a parallelogram? Well, it would be a lot of distance formulas. So distance formula here, they'd have to be the same. Distance formula here, these would have to be the same, right? Right now, we don't have anything for angles to determine the angle, so I'm going to leave that one off. For this one, if we did it by diagonals, you know, there would be a lot there. I mean, you'd have to probably show the midpoint. You'd have to find the midpoint, so use the midpoint formula, and then from there, you'd have to do 1, 2, 3, 4 distance formulas to show that those two are the same and those two are the same. So that would be really a lot of work for that one. But the also that you're going to have to is by this one states show that the quadrilateral JKLM is a parallelogram by using the definition of a parallelogram. Definition of a parallelogram. Well, what is the definition? So that's the way. So they're telling you how. So in your homework, it's going to tell you how to show that it's a quadrilateral. So they're saying show that it's a parallelogram using the definition of a parallelogram. Well, what is the definition of a parallelogram? It's basically that you have two sets of parallel sides, right? So how would you show in a coordinate plane that you have two sets of parallel sides? And what that's going to be is that's going to be a lot of slope formula. M equals y2 minus y1 all over x2 minus x1, right? Excuse me. So you'd have to, right, you'd have to do the slope of this side, slope formula here, slope formula there. They would have to be the same slope. And then slope formula here, and slope formula here, and they would have to be the same slope. And then if you can show that they have the same slope, then these are parallel. And then if these are the same slope, then they are parallel. And so therefore, by the definition of a parallelogram, this would be a parallelogram. Okay, so that's basically what we're doing. We're doing it in a coordinate plane. So we're going to be using a lot of slope formula and a lot of distance formula. Okay? So we're just going to appreciate these first two problems so we see how it's set up and how to solve it. So we're going to show that the quadrilateral JKLM is a parallelogram by using these. Okay, so I'm just going to roughly plot these points. -1, -6, 1, 2, 3, 4, 5, 6. It would be right about there. This is J. K would be -4, 1, 2, 3, 4, -1, so right about there. L is 4, 5, so 1, 2, 3, 4, 1, 2, 3, 4, 5. Roughly there, that's L. And then M is 1, 2, 3, 4, 5, 6, 7, 0. Okay, so this is our quadrilateral, and we're trying to prove that this is a parallelogram. Okay, so the first thing we need to do is find the slope of one set. So what it looks like is it looks like we're finding here the slope of JK here and the slope of LM. Okay, so here J, I have my x1, y1, K is my x2, y2. So here's my slope of JK. and I got my y2 minus y1 all over x2 minus x1. We go ahead and substitute in those points. y2 is -1 minus y1 is -6. My x2 is -4 minus my x1 is -1. You know, those two become positive, so we have -1 plus 6, which is 5. Those two become positive. -1 plus 1 is -3. So that's our slope there. Our slope of JK is 5 over -3. Okay, and now we got to find the slope of LM. So here I called this x3, y3, and x4, y4. So I'm going y4 minus y3 all over x4 minus x3, which is the same thing as this. I'm just using different subscript numbers, which are the little ones. So y4 is 0 minus y3 is 5. x4 is 7 minus x3 is 4. And then we have 0 minus 5, which is -5. 7 minus 4, which is 3. So we have the slope of LM equaling -5 over 3, and this is -5 over 3, okay? So that means they're the same slope, which means they are parallel. So these sides are parallel, so that is awesome, okay? Now, what do we need to do? We need to find the slope of this line and this line. And then if it is parallel, then we know that it's parallel. This is a parallelogram by the definition. Okay, so let's try these. So we have JM, which is the bottom one, and KL right here. Okay, so JM, so J is here and M is here. So my formula is going to be, this is x4, y4, and this is x1, y1. So I'm going y4 minus y1 all over x4 minus x1, right? So we plug in the values. y4 is 0 minus y1 is -6. x4 is 7 minus -1, right? Those two become positive, so it's 6. Those two become positive, so it's 7 plus 1, which is 8. And they have a common factor of 2. 2 goes into 6 3 times. 2 goes into 8 4 times. So we end up with 3/4. That's the slope of JM. Okay? Now we go over here to KL. And K is x2, y2. And L is x3, y3. So the formula is going to be y3 minus y2 all over x3 minus x3 minus x2. We plug in the values. y3 is 5 minus y2 is -1. x3 is 4 minus x2 is -4. Okay, those two negatives become positive. We have 5 plus 1, which is 6. And then these two negatives become positive. We have 4 plus 4, which is 8. And again, there's a common factor of 2. 2 goes into 6 3 times. 2 goes into 8 4 times. So we have the slope of KL equaling 3/4. And if you see, they are the same, which means that those lines are parallel, right? Perfect. Okay, so let's look here. This says since both pairs of opposite sides are parallel, so opposite sides are parallel, both sets. So since both pairs of opposite sides are parallel, JKLM is a parallelogram by definition, the definition of a parallelogram. Okay? So that's how you do it if it's asking you to show that the quadrilateral is a parallelogram by using the definition of a parallelogram. Okay? You would need to do 4 slope formulas. Okay, let's look at the next example. Example 3B, and let's see what this one says. Now this one says, show that the quadrilateral, let me get it right. Okay, show that, my goodness. Show that the quadrilateral ABCD is a parallelogram by using theorem 631. Okay, what's theorem 631? Let's look here. So theorem 631 is this one. So you have to show that there's an opposite side that is congruent and parallel. So in a coordinate plane, that means we're going to have distance formula. A distance formula, they have to be the same distance, which would show that they're congruent. And then we have to figure out the slope of this one, the slope of this one, and if they're the same slope, then we know that they're parallel. Okay, so that's what we're looking for this one. So it's very important, show that the quadrilateral ABCD is a parallelogram by using theorem 631. Okay, So what I'm going to do is just briefly plot this so I just have an idea where these points are. It doesn't need to be real big or anything. I just kind of want to wrap my brain around what this thing looks like. So A is 2, 3. So 1, 2, 1, 2, 3. That's A. B is 6, 2, 1, 2, 3, 4, 5, 6, 2. C is 5, 0. 1, 2, 3, 4, 5. And D is 1, 1. Okay, so this is what it looks like. This is a very mini. Okay, so this is A, B, C, and D. Okay. So it really doesn't matter if we want to figure out the distance of this one and if they're parallel or this one. We just need to pick one, okay? So let's go with A, B, and C, D. So we're gonna pick these two sides, okay? And we're gonna try to show that they're the same distance and that they have the same slope. So let's first go for the slope. So for AB, I'm gonna call A x1, y1, and B x2, y2. Okay, so I'm gonna find the slope of AB, y2 minus y1 all over x2 minus x1, right? I plug in my y2 is 2 minus my y1 is 3. My x2 is 6 minus my x1 is 2. 2 minus 3 is negative 1. 6 minus 2 is 4. There's my slope, negative 1/4. Okay? Then let's look at the slope of CD. This is kind of crooked, isn't it? Okay, so C, I'm going to call this my x3, y3, D, my x4, y4. Okay. So y4 minus y3 all over x4 minus x3. Okay, my y4 is 1 minus my y3 is 0. All over my x4 is 1 minus my x3 is 5. 1 minus 0 is just 1. 1 minus 5 is negative 4. So my slope of CD is 1 over negative 4. And if you look, those are the same. So we know that these are parallel, which is great. That's the first part, right? So we know I'm going to make a little parallel line there because they're parallel. Now we just need to prove that they are the same distance. So guess what's coming? You've guessed it, distance formula. All right. So we're going to find the distance of AB here. Okay, so we know the distance formula is the square root of x2 minus x1, that quantity squared, plus y2 minus y1, that quantity squared. Okay, so AB here, I'm going to, x2 is 6. We've already defined our term. So 6 minus my x1, which is 2, and that's squared, plus my y2 is 2 minus my y1 is 3, and that's squared. So basically we got 6 minus 2, which is 4 squared, plus 2 minus 3, which is negative 1 squared, okay? So the square root of that. So 4 squared is 16. Negative 1 times negative 1 is a positive 1. So we end up with square root of 17, okay? So that's what the distance of AB is. Now let's go ahead and look at the distance of CD, right? So CD is x3, y3, x4, y4, right? Square root of y4 minus x3, no, I'm sorry, x4 minus x3, that quantity squared, plus y4 minus y3, that quantity squared. Then we just go ahead and stick in all the numbers, right? So x4 is 1 minus my x3 is 5, and that's squared, plus my y4 is 1 minus my y3 is 0, 1 minus 0 squared. 1 minus 5 is negative 4 squared, plus 1 minus 0 is 1 squared. Negative 4 times negative 4 is 16, plus 1 times 1 is 1. 16 plus 1 is 17. So boom, there we have it. CD is equal to the square root of 17. Perfect, perfect. So that means that they are the same distance. So they are parallel, right? They have the same slope and they have the same distance. So then AB, line segment AB and CD have the same slope. So that means that AB is parallel to CD, right? AB is parallel to CD. And since AB is equal to CD, that means that 8B is congruent to CD. So by the theorem 631, ABCD is a parallelogram. And remember that theorem 631 is just a quadrilateral with pair of opposite sides, parallel and congruent, then it must be a parallelogram. Whew, that was a lot. Okay, perfect. So now it is your turn to check it out. So, but we need to be sure on how we are going to show that it's a parallelogram. So it says use the definition of a parallelogram to show that the quadrilateral with these vertices is a parallelogram. So use the definition. So definition of a parallelogram, that's how you have to prove it. And remember, the definition of a parallelogram, I'm just going to leave it like that. Okay, so you go for it. Where's my friend? Here's my pause dragon friend. Go ahead and work this problem out. When you get done, press play and we'll talk about it. All right, see you in a bit. Okay, I'm just briefly going to plot this. K is negative 3, 0, 1, 2, 3. L is negative 5, 7, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Okay, and then, yeah, so this is L. M is 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. Right there. And then N is 5. What was this? M. And this is K. K, L, M. And then N is 5, 1, 2, 3, 4, 5. And then down to, which is right about there. Okay. So it kind of looks like this. So we know what we're dealing with, right? Okay, so we are going to have to show that it's a parallelogram by definition. I am going to go ahead. Oh, we already have these. X1, Y1, X2, Y2, X3, Y2. So that means we have to show that these two sides are parallel and these two sides, right? So it's a lot of slope formulas. So let's go ahead and get started. Let's try to find the slope of these two first. Okay, so let's see. Okay, so we're going to find the slope of KL. And that's going to be, what's KL? Oh, Y2 minus Y1 all over X2 minus X1. We stick in everything. That's 7 minus 0 all over negative 5 minus negative 3. And then that's 7, and that's plus. Negative 5 plus 3 would be negative 2. So there's the slope there, negative 7 over 2. Did I do that right? Yeah, I think so. Yes, I did. Okay, and then, so we have the slope of KL. Now we have to find the slope of MN. So slope of MN is going to be, okay, so here, so it's going to be Y4 minus Y3 all over X4 minus X3. Y4 is negative 2 minus Y3 is 5 all over X4 is 5 minus X3 is 3. That ends up negative 2 minus 5 is negative 7 over 5 minus 3 is 2. So that's the same thing. Okay, perfect. We know that these are parallel, same slope. Okay, now let's go ahead and find the slope of these two other lines here. So, I'm going to change the color. Let's go slope of ML, or LM, right? I guess LM would make more sense. So LM is right here, so Y3 minus Y2. Y3 minus Y2, that's LM. And X3 minus X2. Y3 would be 5 minus Y2 is 7 all over 3 minus a negative 5. 5 minus 7 is negative 2 over plus, that's 8. And 2 goes into both of those. 2 goes into 2 one time, 2 goes into 8 4 times, so we're going to end up with 1/4. So that is our slope of that one. Okay, now what was that? LM. Okay, now we got to do KN. So we're going to go slope of KN. And that's going to be, okay, so this one's going to be y4 minus y1 all over x4 minus x1. -2 minus 0, 5 minus -3. That's just -2 over, those are plus 8. 2 goes into there 1 time, 2 goes into there 4 times. So there we have it, -1/4. They are the same, which means that these are also parallel. And I'm going to put 2 marks because these are parallel, but they're not parallel to those. So we got one parallel mark there, 2 parallel marks there. Perfect. So since both pairs of opposite sides are parallel, JKLM is a parallelogram by definition. All right, so if you got all that right, yoga nikimashita, you did a wonderful job. If not, go ahead and fix yours so it looks just like mine. All right, see you in a little bit for example 4.